Okay, today we're going to do textbook chapter 7, practice test number 3. So the first problem is a system, and we are supposed to use substitution. So there we go. Now remember, when we substitute, we look for a variable that we can get all by itself. So actually we have a couple of choices here, so it doesn't matter. Just pick one. I'm just going to say x equals negative y. I'll move the y to the other side. And then I will take this guy right here and substitute him in for x. So 2 times negative y plus 3y equals negative 1. Taking that negative y and sticking it right in here in place of x, substituting it in for x. So negative 2y plus 3y equals negative 1. Collecting like terms, y equals negative 1. Remember, our answer is supposed to be an ordered pair, so we now know the y coordinate is negative 1. Now, if we come back up anywhere, any of these equations here, and put in negative 1 for the y, it'll give us our x. So I'm going to put it in right here. So x equals negative 1, which is positive 1. And there's the answer to the system. Now, we're going to do exactly the same type of problem, but we're going to do it with elimination. So notice the problem looks exactly the same. You could do this problem using substitution if you wanted to, except we are supposed to use elimination according to the sheet. So if I'm using elimination, then my job is either to make these disappear when I add them, or to make these disappear when I add them. And it looks like the easiest choice, you could do either one, but the easiest choice will be to multiply this equation by negative 3. So my top equation is going to stay the same. And then I'm going to multiply the bottom one by negative 3. So I have negative 9x, negative 3y, and 15. Now notice you did that so that these would be eliminated. You're adding straight up and down, and those are eliminated. So negative 7x equals 7. So it looks like x is going to be negative 1. So then we'll go back, and just like we did a minute ago, we'll take that x value. Now that's an x value. We'll take that and we'll put it in somewhere. It doesn't matter where. I think I'll put it in the bottom one. So if I put in negative 1, I have 3 times negative 1 plus y equals negative 5. I'm putting it in this equation right here. So negative 3 plus y equals negative 5. Now add 3, so y equals negative 2. So x is negative 1 and y is negative 2. And that is the answer to the problem. Okay, now we're going to do one more problem that looks exactly the same, except this time we're going to use Cramers Rule to solve. So remember, Cramers Rule is the method that uses the determinants. So the first thing we do is find the determinant for our x's and our y's. So we have 2 and 3 for the x's, negative 1 and 5 for the y's, are the coefficients. So we're going to evaluate that. So it's 2 times 5, 3 times negative 1, and then we subtract those. So it's 10 minus negative 3. So that's 13. And that 13 becomes the denominator of our x and our y. So whatever x and y turn out to be, the denominator is going to be 13. So here's my answer, and the denominator is 13. Okay, now we got to find the x numerator, this guy right here, the x numerator. So it's another determinant, and so is the y numerator. And to find them, we replace some of these numbers with the 7 and the 1. So if I'm doing x, I'm going to cut these out and paste them right here on top of the x's. These are my x numbers. So I'm going to have 7 and 1 in the x spot, and then I'll still have my negative 1, 5 in the y spot. And then to do the y numerator, same thing, only these replace the y's. So I still have my 2 and my 3 in the x spot, but now I have 7 and 1 in the y spot. So now I will evaluate those, just like I did this one. So it's 35 minus negative 1. 35 minus negative 1. So that's 36. And then same thing here, 2 minus 21. 2 minus 21. So that's negative 19. And there is the solution to that system. So we have done 3 problems there on that front page that are all basically the same problem. We just did it 3 different ways. Okay. All right. So now we're on the next page where we're doing just a whole page of just matrix operations. So the first problem says we're going to multiply matrix A times matrix D. Okay, so the problem says multiply matrix A times matrix D. Well, before you jump in and start doing this, we got to make sure we even can. So the dimensions of this matrix right here are 2 rows and 3 columns. The dimensions of this matrix are 3 rows and 3 columns. Guess what? We can multiply. And our answer will be a 2 by 3. So it'll look just like this one. Now in a minute, I'm going to start filling up those spots. And to fill this one, I'm going to use the first row, first column, because that's where this is. It's in the first row, first column. First row, second column, first row, third, second row, first, second row, second row, third. So I'm going to fill all those spots, and I'm going to do that using each row and column for that respective position. So right here, I'll start with the first row and the first column. So I'm going to write down the numbers in the first row, which are 1, 2, negative 1. And then next to them, I will write the numbers in the first column, which are 1, 3, 0. I'm going to multiply each pair of numbers and add them up. So 1 plus 6 plus 0. So that number is a 7. Okay, now I'm going to move over here, and I'm going to multiply the first row of numbers times the second column of numbers. So I have the first row times the second column now. So I'll multiply each pair. So I have 2 plus 4 minus 1, which is 5. And then finally, we'll do the first row of numbers again. So that's still the 1, 2, negative 1. Times the last column, which is negative 1, 1, 2. And I'll multiply each pair and add them up. So I have negative 1 and 2 and negative 2, so it looks like that's going to be negative 1. And there's your top row. Now, to get this set of numbers, I'm going to do exactly the same thing, but instead of using row 1, I am going to use row 2, because these are all in the second row, so I'm using the second row. So I'm going to write down 0, 3, 4, and then if I'm filling in this spot, I'll use the first column, 1, 3, 0, multiply each pair and add them up. Well, look, that's a 0 and that's a 0, so it's just going to be 9. Now the bottom row, or yeah, I'm looking for this, so I'm going to use the bottom row again. And this time the second column, 2, 2, 1, second column, second column. So it looks like I have a 0, a 6, and a 4. So that guy's a 10. And finally, second row, third column. So there's my 0, 3, and 4 again, second row. Third column, negative 1, 1, 2. So I have 0, 3, and 8, so that's 11. And there it is. We multiplied A times D. All right, the next problem says we're going to do C plus 2A. So that's going to be negative 2, 2, 5, 1. That's C. And then 2 times A, which is this one again. And we're going to add those together. Now, hopefully, you have recognized that that is not possible. That is not possible because if you are going to add matrices, they must be exactly the same size. And this guy is a 2 by 2, and this guy is a 2 by 3. 2 rows, 2 columns, 2 rows, 3 columns. So there is no way that those can be added. That is no solution, can't be added, dimensions don't match. However you want to explain it, there's no answer to that problem. So, on to the next one, which is 2B minus 3c. Okay, so 2b and 3c. Now, this problem is going to be doable because the rule for subtraction is the same as for addition. We have to have the same size. So this is a 2 by 2, 2 rows, 2 columns. This is a 2 by 2, 2 rows, 2 columns. So we can do this problem. So we will start by distributing, multiplying this scalar, this number 2 here, this number, we're going to multiply it times everything in there. So we end up with negative 2, 4, 6, 2. Minus, now I'm going to go ahead and leave that a minus. So I'm just going to distribute the 3. You could also distribute a negative 3 and make it a plus if you wanted to. I don't know which way you want to do it, so I'm just going to do it this way. So I'm going to leave it a minus. It's a subtraction problem. And this is going to be negative 6, 6, 15, 3. So I took 3 times all of those numbers. Now I'm going to subtract. Squeeze it in over here. When I subtract, remember, I subtract corresponding positions. So you are subtracting. So it's negative 2 minus negative 6. Watch your arithmetic. Negative 2 minus negative 6. So that's going to be 4. Four minus 6. Ooh. 6 minus negative 15. And finally, 2 minus 3. And there's the answer to the question. Excuse me. Now, the next one says, find B inverse. So this is matrix B right here. And we're going to find the inverse. Now remember, finding the inverse is a two-step process. The first thing you have to do is find the determinant. So when we find the determinant, we did this earlier with Cramers Rule, we multiply this times this, we get negative 1. This times this, we get 6, and we subtract. So the determinant is negative 7. Negative 1 minus 6. Now we build a new matrix. And the new matrix is found by taking these two, look where my fingers are, and flip-flopping them. Now, because those numbers are the same, it's going to look like I changed their signs, but I didn't. I physically flip-flopped those two numbers. These two flip-flop. So this comes up here and this comes down here. They change location. These two change their sign. So the 3 stays here, but it becomes negative. The 2 stays there, but it becomes negative. This 1 goes here. This negative 1 goes here. They flip. Then we take each of those numbers in this new matrix and divide by the determinant. And then do any simplifying that you can. So we got negative 1/7, positive 2/7, positive 3/7, and positive 1/7. And that is the inverse. Okay? Next, we are going to do negative 2b. Oh shoot, I shouldn't have erased b. So b is this matrix. So we're just going to do negative 2 times b. Well, that's really easy. Just take negative 2 times everything. So we get 2, negative 4, negative 6, and negative 2. Done. That's easy. Negative 2 times each of those numbers. And now we have another multiplication to do. So, oh shoot, matrix B again. And then D. And we're going to multiply these. Oh, no, we're not. No, we're not. Because this is a 2 by 2 and this is a 3 by 3. And what is our rule for multiplication? Our rule for multiplication is these two must match. They don't. So guess what? This is another can't do it. Cannot multiply because these two dimensions don't match. Okay, well that brings us to problem number 5, which is a determinant make sure I copied it right. All right, now we're going to evaluate this determinant. So do you remember how to do this? When we evaluate this guy, we have to recopy our first two columns. So 1, 0, 4 goes right here. Negative 1, 3, negative 2 goes right here. And then we're going to multiply on this diagonal right here. So we start right here. So we get 9. And then we'll multiply these right here. We get negative 4. And we multiply these right here, and we get 0. Then we add all those up. So we have a 9, a negative 4, and a 0. So we add all that up, and we get 5. Now we're going to go in the opposite direction. And you got to do it in this order, kids. That's why I made that one red. I want you to start with that one. That's the first thing you should do. Okay, so I'm going this way now. So that's 24. Negative 2 and 0. So I'm going to add up a 24, a negative 2. You're multiplying, and a 0. It's 22. Then to get our final answer, we're simply going to subtract 5 minus 22. So our answer is negative 17. That's the final answer to the problem. 5 minus 22. Okay. Now we have a little vocabulary section. Got to know our vocabulary. So we're going to start with this matrix right here. Okay. And we're going to answer some questions about it now. Question A says, is it square? And the answer is no, it's not square. Why? Because it doesn't have the same number of rows as columns. This matrix is a 3 by 4. 3 rows, 4 columns. If you're square, these two numbers match. Oh, by the way, this is the answer to C, because C says, what are the dimensions of B? 3 by 4. 3 rows, 4 columns. Question B says, find that. Well, this is matrix B, remember? So this tells me to look inside matrix B, go to the second row, third column. So second row, third column, that is -2. We're in the second row, third column. So this is the entry that's in the second row, third column. Define scalar. A scalar is simply a real number. A scalar is a real number. A matrix is a rectangular array of numbers arranged in rows and columns. That definition is in your notes, and it's on the other 2 practice tests. A matrix is a rectangular array of numbers arranged in rows and columns. Okay, now we have our linear programming problem. A, B, total. Okay, and I don't have much room, so I'm going to go ahead and, well, let's start filling out the chart first. All right, here we go. We're going to take a test that contains questions of type A and type B. Type A is 10 points, and type B is 25 points. That's their value. You must do at least, all right, now pay attention to this. You must do at least 3 questions of type A, but time restricts doing more than 12. So if we let X be the number of type A questions, then X has to be between 3 and 12. The fixed interval, that is the interval of possibilities that you have for type A questions, is at least 3, but less than or equal to 12. And then if you let Y be your B questions, then that interval is 4 to 15. Read the question. You must do at least 4, but no more than 15. In total, you can do no more than 20 questions. So the total number of questions is 20. We want to maximize our score, and your score will be calculated by 10x plus 25y, because every x is worth 10 and every y is worth 25. Okay, so now I got to figure out what my constraints are. You know, we're going to graph. In a minute, we're going to graph. What are we going to graph? Well, x plus y has to be less than or equal to 20. I don't have room for my constraints over here because I made my chart too big. So these are the things that come over here. These are your constraints. X plus y is less than or equal to 20. This is a constraint right here. This is another one. And these two take care of it. But remember, you are always welcome if you want to do x is positive and y is positive. You don't have to put those in there, but it's never going to be wrong to put them in, because certainly it's true that x and y have to both be positive. We can't do negative questions. Okay, so now we got to graph it, and as always, feel free to extend your chart, your grid, or to use a different scale. I think I'm going to go ahead and just use 1 as my scale. You can too, if you just extend it a little bit. Okay, so here's my grid. I'm ready to go. So I'm going to start right here with this one. I'm going to do this one in red. Notice it has an X and a Y, so it's going to be a diagonal line. I'm going to plot a point on the X-axis and a point on the Y-axis. So I'm going to cover up X, let X be 0. So Y is 20. So I'm going to go ahead on my Y-axis and count up 20. So I'm clear up here. Clear up here. That is the point 0, 20. All the way up straight up my X or my Y-axis. Now I'm going to do the same thing. If I let X be 0, excuse me, if I let Y be 0, then X is going to be 20. So I count down on my X-axis. I count out 20. So it's clear down here now. And now I'm going to connect those 2 points with a nice little diagonal line. So now I have this. And since it's less than, I'm going to be shaded below. So far, I am looking at the triangle created by the point 0, 20, and 20, 0. Okay. Now, I'm going to graph this one in blue. Now, notice that it only has x's. So I am only going to be graphing on my x-axis. So I'm going to put a point at 3, 0, and a point at 12, 6, 7, 9. So I've got a point at 3 and a point at 12, 0. And then I'm going to draw my vertical bars just straight up the 3 line and straight up the 12 line. So it looks like that. And I am shaded in between. So now I am shaded below the red and in between the blue. So I'm looking at this section right here, right now. Now in purple, I'm going to graph this one. Notice that it has only a Y. So I'm going to go up the Y-axis only and put a dot at 4 and a dot at 15. And I'm going to draw those straight across horizontally. So there are my purple lines. This one's at 4, that one's at 15. And I am in between the purple lines. So keep in mind, I'm between the blue, under the red, and between the purple. So the section that I am looking at, I'm going to outline. Looks like this right here. This is the section I'm looking at. And I have a point here, 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 and here. So those are the points that I now have to identify. Okay, some of them are super simple. This guy, for example, is super simple. This X is 3, and this Y is 4. So that is the point 3, 4. So I'm going to go ahead and write those points down. Remember, there's 5 of them. Okay, so I did this one. It's 3, 4. Now, this one's equally easy because its X is 12 and its Y is 4. So that's 12, 4. This one right here is equally easy because its X is 3 and its Y is 15. Remember, if you're on a vertical line, your X is whatever it is. If you're on a horizontal line, your Y is whatever it is. So this is on the vertical line where X is 3 and the horizontal line where Y is 15. Now, we've identified all of these. These are the trickier ones, but they're still super simple. Let's look at this point right here. We know its X is 12. But if you are on the red line, like these 2 points are on the red line, then you know X plus Y has to add up to 20. So if you know your X is 12, if X is 12, then Y must be 8. Because they have to add up to 20. Similarly up here, we know that Y is 15, and if Y is 15, then X has to be 5. So there are the corner points of our graph. And now we are going to maximize our score. So to do that, remember, this is how you calculate your score. So we're simply going to take, for each of these points, I'll start with that one, we put the X in for the X and the Y in for the Y, and we figure out what that is. So 10 times 3 plus 25 times 4. So that score would be 130. I'll put them in a different color so they show up. So this one has 130. All right, so then I come down here, and now I put in 12 and 4. So 10 times 12 plus 25 times 4. So that's 220. Now I'm going to put in 3 and 15. So 10 times 3 plus 25 times 15. That's 405. Oops. $12 and 8. 10 times 12 plus 25 times 8. And finally, 10 times 5 plus 25 times 15. Now, your job, if we go back to the problem, your job was to say how many of each type of questions must you do to maximize your score, and what is the maximum score. So, finally you write, I should do, let's see, right here, 5 A's and 15 B's, and my score will be 425. Okay, awesome. All right, one more problem now is our calculator problem. So remember, we got to write down the matrix we're using. So it looks like our variables this time are E, F, G, and H. Boy, I don't know how I'm going to do this. Let's see. Anyway, there it is, E, F, G, and H. So we have 1 E, 2 F's, negative 3 G's, 1 H, and it equals negative 8. So there's the first row. Then we have 1 E, 1 F, negative 1 G, negative 1 H, and negative 1. 2 E's, no F's, negative 3 G's, 4 H's, and 2. And then no E's, no F's, 1 G minus 1 H, and equals 2. So there is the matrix that went in. So again, if you're looking at your equations, you have E plus 2F minus 3G plus H equals negative 8. E plus F minus G minus H equals negative 1. 2E minus 3G plus 4H equals 2. And G minus H equals 2. Remember, if a letter is missing in your matrix, you have to put in a 0. So the bottom equation has no E's or F's. Your answer is going to be E, F, G, H. You get numbers here. But to get those numbers, we're going to have to get this matrix into our calculator. So, we're going to go into matrix. So, second matrix. Click across to edit. Press enter. What are the dimensions of this matrix? This matrix has 1, 2, 3, 4 rows and 1, 2, 3, 4, 5 columns. So this is a 4 by 5. So 4, enter, 5, enter. And now our matrix is set up and ready to go. So we just start typing in all of these numbers. So I'm going to start by pressing 1, enter, and then I'll come over and press 2, enter, and so on. Remembering that when I plug in a negative sign, I'm careful to use my negative button right here. This is your negative button. And just do each row. When you get to the very last number, this 2 right here will be the last one you put in, press enter. And as soon as you get that 2 in and you press enter, then second quit. Second quit. Now we're going to go back in to the matrix menu. So second matrix again. And this time you're going to go over to math. When you're putting the numbers in, you go all the way over to edit. Now that they're in, we'll just go over to math. And then click all the way down to RREF. RREF, that's the button we need. I don't have room here, so I'm going to now write down my new matrix. So we have RREF, and now we're going to get this new matrix right here in just a minute. So go down to RREF, press enter, and then second matrix, enter, enter, and you should come out with this. Now, believe it or not, that is your answer. If you didn't get that, go back and double check and make sure that you put your matrix in right. I mean, that's the only place really that you could make a mistake, is by not putting the original numbers in correctly. And so what does this tell me? This tells me E is 4, F is -3, G is 2, and H is 0. And that is the solution to the system of equations that we started with that I erased. So again, use second matrix, click across to edit, put in your dimensions 4 by 5, and then put in all the numbers of the original matrix. Second quit, then second matrix again, over to math, down to RREF, enter, second matrix, enter, enter, and this should pop up. And that is it for practice test 3.